We know that the measures of central tendency, that is the mean, median and the mode, they all tend to fall in the center of the given data. Whatever is the data given, out of that the highest value and the lowest value, so whatever the difference between the two, that we call it as the range. Only 1/4 of the values of the series are more than Q3. So in Q1, only 1/4 of the values are below the Q1 and 3/4 of the values are more than the Q1. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session, let us have a discussion on measures of dispersion. So the measures of central tendency reflect a single numerical value which describes the entire data. They are helpful in describing the huge numerical data with only one number. So the measures of dispersion are used for understanding the uniformity in data. So we know that the measures of central tendency, that is the mean, median and the mode, they all tend to fall in the center of the given data. Now these measures of dispersion are used for understanding the uniformity in the data. Thus the techniques of dispersion measures the degree of scatter of values of series from its average value. They show the variability in the values. Therefore, the measures of dispersion are known as the measures of variation. So, the measures of dispersion are also called as variation because they measure the distance from the value to the average value. So, the dispersion or the spread is the degree of the scatter or variation of the values about the central values. The dispersions can be measured in two ways: the absolute measure and the relative measure. Absolute dispersion refers to the measure of values in the same statistical units as given in the original data. So whatever the units are given in the original data, the absolute dispersion will have the same units, whereas the relative dispersion measures the variability indirectly as a percentage or a coefficient of values. So they refer to a ratio of the measure of absolute dispersion to an average. Then in the measures of dispersion, the first one is the range. The range is the difference between the highest and the lowest values of the variable under study. So whatever is the data given, out of that the highest value and the lowest value, so whatever the difference between the two, that we call it as the range. In individual and discrete series, the range is calculated by taking the highest and the lowest value of the variables. In frequency distribution, the range is calculated by difference between the upper limit of the highest class and the lower limit of the lowest class. The range is not influenced by frequencies. Symbolically, the range is L minus S. So, in case of a frequency distribution table, we should understand that the range is the highest value of the last class interval and the lowest value of the class interval. So, the range is not influenced by the frequencies, where see the range, the formula for range is L minus S, where L is the largest value and S is the smallest value in a distribution. The coefficient of range, which is a relative measure, is calculated by the formula L minus S divided by L plus S. So, the range equals L minus X divided by L plus S. Now, we have a problem here. So, compute the range and its coefficient for the data relating to the heights of students in inches. So, they have given the height of students. This is in inches and this is the number of students given, that is the frequency is given. Now, how do we find the range here? Very simple. What is the height of the tallest boy of the class? 72. Now, the largest value is 72. The smallest value is 60. Now, the range will be equal to L minus S, that is equal to 72 minus 60, that is equal to 12. So, the range is equal to 12. So, this is the answer, or I write range equals 12. This is the answer. Next, we have the one more illustration here. Compute the range and its coefficient for the following data. So, they have given us the class intervals here. So, the lowest class interval equals 20 to 30 and the highest class interval equals 100 to 110. Now, the range will be equal to 110 minus 20. So, the range is equal to, so this is the highest limit of the last class interval and the lowest limit of the class interval. So, 110 minus 20, so the range equals 90. So, R equals 90. We have to calculate the coefficient of range. Coefficient of range equals L minus S divided by L plus S. So, this will be equal to 110 minus 20 divided by 110 plus 20. So, this will be 90 divided by 130. So, the answer is 0.69 is the answer. Now, the next one, calculation of range continuous series. Now, quartiles are positional averages which have been explained in the measures of central tendency. Now, in these measures of dispersion, the first one is the range, the second one is the quartiles. Now, what are these quartiles? These quartiles are positional averages. That means they are based on the position, that is the Q1, Q2 and Q3. So, we have the quartiles there. So, they are positional averages which have been explained in measures of central tendency. They are also used for understanding the variation in the data. In fact, they are better known as measures of dispersion rather than measures of central tendency. Quartiles divide the series into 4 equal parts. Now, if you are given a series of numbers, so these quartiles, they divide the series into 1, 2, 3, 4. Now, Q1, Q2, Q3. So, if have this, find this Q1, Q2, Q3, so they will divide the entire series into 4 equal parts. Now, the first quartile Q1 is also known as the quartile of the series. The 3/4 of the values in the series are more than the value of the first quartile. Now, this one is the Q1 and then the 3/4 of the values, they will be more than this Q1. Then, and 1/4 is below this value. So, this part will be 1/4. So, this 1/4 will be below the value of Q1. The second quartile or M or the median is the middle of the quartiles. Now, this Q2 we call it as the median and it is the middlemost value of the series. So, which divides the series into 2 equal parts. The third quartile is Q3, the upper quartile of the series. Now, this we call it as the upper quartile and this is the lower quartile. So, the quartiles are lower quartile, median and the upper quartile. So, 3/4 of the values of the series are less than the third quartile and 1/4 are more than it. So, here if you can see, only 1/4 of the values of the series are more than Q3. So, in Q1 only 1/4 of the values are below the Q1 and 3/4 of the values are more than the Q1. Now, the interquartile range is an absolute measure which points out the difference between the quartiles. Quartile deviation and its coefficient are also computed on the basis of the first and the third quartiles. So, whenever we have to calculate a quartile deviation, so they are computed on the basis of the first and the third quartiles. Quartile deviation is the average of the differences of the third quartiles. It is known as semi-interquartile, which is an absolute measure of the variation. So, the interquartile range equals Q3 minus Q1 and the quartile deviation is Q3 minus Q1 divided by 2, or we also call it as the semi-interquartile range, and then the coefficient of quartile deviation is Q3 minus Q1 by Q3 plus Q1. So, if we have to find the quartile deviation, so the formula is Q3 minus Q1 divided by 2. Now, we have the calculation of quartile deviation individual series. So, arrange the data either in the ascending order or the descending order and locate the quartiles by using the following formulae. So, Q1 can be found by the size of n plus 1 by 4th item of the series, and Q3 is size of 3 into n plus 1 by 4th item of the series. So, we have this Q1 and Q3. So, we have a problem here. Calculate interquartile range, quartile deviation and its coefficient for the data given below. So, whenever you are given the data in the problem, so first thing is we have to arrange the data in the ascending order, and then we have to find the range and the quartile deviation. So, first we will arrange the given values in the ascending order. So, I write x. Then what is the smallest number given here? 35, then 48, then 52, then we have 60, then 62, 65, then 78, then 90, then 94, 95, 99. Yes, so we have arranged it in the ascending order. So 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 11. So I have here in the ascending order, I have written all the values. Now I have to find the Q1. Q1 equals the size of n plus 1 by 4th item. Okay, the size of n plus 1 by 4th item. Now, what is n here? N equals 11. So, Q1 will be equal to 11 plus 1 divided by 4th item. So, this will be equal to 12 divided by 4, that is the third item. So, the third item of the series is 52. So, this becomes the Q1. Now, I have to find Q3. So, Q3 will be the size of 3 into n plus 1 by 4th item. So, this will be equal to 3 into 12 by 4. So, this will be equal to 9th item. So, what is the 9th item here? So, I have to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9th item is 94. So, that is equal to 94. So, now I have to find the interquartile range. So, what will be the range? Range will be equal to Q3 minus Q1. So, in order to find the range, I have to find the difference between Q3 and Q1. So, this will be equal to 94 minus 52, that is 42. So, 42 will be the range. Now, I have to find the QD, that is the quartile deviation will be Q3 minus Q1 divided by 2. So, the 42 divided by 2, that becomes 21. Now, they have asked me the coefficient. The coefficient will be Q3 minus Q1 divided by Q3 plus Q1. So this will be equal to 42 divided by 94 plus 52. So this will be equal to 42 divided by, so I just add 94 plus 52, 146. So when I simplify this, so 42 divided by 146, I get the answer as 0.287, or so we have here the coefficient of quartile deviation is 0.29. Now we'll go to the next part of the series here. So the quartile deviation, the discrete series. So the computation of quartile deviation, coefficient of quartile deviation requires the following steps. So first, compute the cumulative frequencies from the frequencies. Identify Q1 and Q3 by application of the formula. Q1 equals size of n plus 1 by 4th item of the series. Then Q3 equals size of 3n plus 1 by 4th item of the series. So when you are given a discrete series, that is values along with the frequency, then the first step will be you have to add the cumulative frequency, add all the frequencies. The second step is identify the Q3 and Q1. So again we have the same formula here. So we just identify the Q3 and Q1, and then we have to find the QD, the coefficient of quartile deviation. So here we have a problem here. So the computation of interquartile range, quartile deviation and coefficient of quartile deviation from the given information. So the x values are given and also the frequency also is given. So I write it in the vertical manner. So x values will be 20, 22, 25, 28, 32, 36, 40, 44, 50, 60, 64, 66, 68. So these are the x values. Now the frequency values will be 3, 6, 10, 15, 20, 24, 30, 22, 18, 14, 10, 6 and 6. So they have given us the discrete series here. So when we are given the discrete series, that is along with the frequency when values are given, the first step will be find the CF. So CF is 3, 3 plus 6 is 9, 9 plus 10 is 19, then 19 plus 15 will be equal to 34, 34 plus 20 will be 54, 54 plus 24 will be, so 54 plus 24 will be equal to 78, 78 plus 30 equals 108 plus 22 equals 130, 148, 148 plus 14 equals 162, 172, 178, 178 plus 6, 184. So we have the CF here. Now once we had done with the CF, now we have to find out the Q1. Q1 equals the size of n plus 1 by 4th item of the series. So this will be, what is the size of the series? 184. So this will be 184 plus 1 divided by 4. So it comes up to 185 divided by 4. 185 divided by 4 equals 46.25th item. So now we have to identify here. So up to 28 values it comes here. From 34 to 54 it is the 32. The Q1 will be the 32. Now we have to find out Q3. So Q3 will be equal to the size of 3 into n plus 1 by 4th item. So this will be equal to 3 into 185 divided by 4. So 185 into 3 equals divided by 4 equals 139. So it is 138.75. So I round it up to 139. So 139 means up to 130 it comes here. Now from 130 to 148 it comes here. So Q3 will be equal to 50. So 50 is the value of Q3. Now we have found Q1, we have the Q3. Now we find the interquartile range. So the interquartile range equals Q3 minus Q1. So this will be equal to 50 minus 32. 50 minus 32, that is equal to 18. Now quartile deviation will be Q3 minus Q1 divided by 2. So that is 18 divided by 2, that is 9. Now coefficient of QD. Now the coefficient of QD will be equal to Q3 minus Q1 by Q3 plus Q1. So this will be equal to, so Q3 minus Q1 is 18, Q3 plus Q1 will be 50 plus 32, that is 82. So 18 divided by 82 equals 0.219 or 0.22. So this is the answer. The coefficient of quartile deviation is 0.22. The quartile deviation is 9 and the interquartile range is 18. So in this way we have to solve the problem which is given. Now we go to the next. Now calculation of quartile deviation continuous series. Calculation of quartile deviation continuous series is possible when the size of the class interval is equal throughout the distribution. If series is formed in an inclusive method, it should be converted into an exclusive form. If mid values are given, it is necessary to determine the class intervals. So compute less than cumulative frequency. Find out Q1 and Q3 classes by using the following formula. So Q1 is n by 4, Q3 is 3n by 4. So after locating the quartile class, substitute the values L, C, F and I in the formula. Now for the previous, for the discrete series, we had a different formula. So we could just 3n plus 1, n plus 1 by 4th item will be the Q1 and 3n plus 1 by 4th item will be the Q3. But here we have a different formula here. So we have to use this formula, that is L plus n by 4 minus CF divided by F into I. So for Q3 it is L plus 3n by 4 minus CF divided by F into I. So we have a, where L is the lower limit of the quartile class, CF will be the cumulative frequency preceding the quartile class and F is the frequency of the quartile class and I equals the class interval. Now we have a problem here. So calculate quartile deviation and its coefficient for the marks of 215 students. Now they have given us the marks of 215 students here. So 0 to 10 is 10. 10 students have scored between 0 to 10. 10 to 20 is 15. Then 28, 32, 40, 35, 26, 14, 10 and 5. So these are the frequencies of the various class intervals. So based on this, we have to calculate the quartile deviation. So the marks of the students are given. So I write it in the vertical form: 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. So these are the various class intervals given. Now the frequency also is given here. So this is 10, 15, 28, 32, 40, 35, 26, 14, 10 and 5. So the frequencies are given. Now we have to find the CF. The CF will be 10, 25. So next I have to add all the frequencies here. So 10 plus 15 is 25. 25 plus 28 will be 53. 53 plus 32 will be 85 plus 40, that will be 125 plus 35, 160 plus 26, 186 plus 14, 200, 210, 215. So this is the CF given here. So we have the frequencies, we have the marks of the students here. Now we have to just identify the Q1 and Q3. Now how do we find Q1? N by 4. So n by 4, so this will be equal to 215 divided by 4th item. So this will be equal to 215 divided by 4. So that will be 53.75 or 54. Now I have to see where this 54 lies. So up to 53 it lies from between 20 to 30. From 53 to 85 it lies between 30 to 40. So the class interval of Q1 equals 30 to 40. So we have this 30 to 40 as the class interval. So now I have the formula. So Q1 equals L plus N by 4 minus CF divided by F into I. So this will be, what is the lower limit of the class interval here? 30. So 30 plus N by 4 is how much? 53.75 minus CF is 53 divided by frequency of the class is 32 into 10. So this will be equal to 30 plus, so 0.75 by 32 into 10. So this will be equal to 0.75 into 10 divided by 32. So this will be 30 plus 0.23. That will be 30.23. So Q1 equals 30.23. Now we have to find Q2. So we got Q1 equals 30.23. Now Q2 will be 3n by 4. That will be equal to, just see here, what is n here? 215 by 4. So 3 into 215 divided by 4. So this will be equal to 3 into 215 equals, so divided by 4 equals 161.25 or 161. Now we will see in this previous where 161 falls here. So it will be between 60 to 70. So 60 to 70. Then we also have the frequency and the cumulative frequency. So I write here in the next slide here, I write the class interval is between 60 to 70, and next, what is the frequency? Frequency is 26, F equals 26, CF equals 160, I equals 10. Now I substitute the values here. So Q3 will be equal to L plus 3n by 4 minus Cf divided by F into I. So this will be, what is the lower limit of the class interval? 60 plus 161 minus 160 divided by 26 into 10. So this will be 60 plus, so 161.25 minus 160 divided by 26 into 10. So 0.48. So that will be 60.48. So Q3 equals 60.48. Now we have Q3 and Q1. So I have to find the interquartile range will be Q3 minus Q1. So Q3 is 60.48 minus 30.23. So this will be equal to 60.48 minus 30.23 equals 30.25. 30.25. Then we also have the QD will be equal to Q3 minus Q1 divided by 2. 30.25 divided by 2. So divided by 2 equals 15.12. So quartile deviation is 15.12. Next will be the coefficient of QD. Coefficient of QD equals Q3 minus Q1 by Q3 plus Q1. So this will be equal to 60.48 minus 30.23 divided by 60.48 plus 30.23. So this will be equal to 30.25 divided by 60.48 plus 30.23 will be equal to 90.71. So when I simplify this, so 30.25 divided by 90.71, this comes up to 0.333. So the coefficient of quartile deviation is 0.333. So this is the answer. So we have to calculate the Q3, Q1, and then we have to calculate the interquartile range, the quartile deviation and the coefficient of quartile deviation. With this, we come to the end of this session. Hope you have all followed it. Thank you.